So here's something that I definitely hinted at toward the end of the last section. What if we wanted to consider what goes on as far as a derivative is concerned, but we don't want to have to worry about what variable we're actually plugging into it? So when we defined the derivative at a point, we came up with two different limit definitions for it. One of them was the limit as x approaches a of f of x minus f of a all over x minus a, and that worked out just fine. The other possibility was the limit as h approaches 0 of f of a plus h minus f of a all over h. So in this section, we're going to be posing the question, well, if a is a variable anyway, why don't we just leave a as x? Can we leave a as a variable? Well, let's see what happens when we take these two definitions and we change all of the a's into an x. So this would be the limit as x approaches x of f of x minus f of x all over x minus x. So you may have noticed that that one's not going to work out great because we're taking the limit as x goes to x. Well, x is already x, and your numerator is exactly 0, and your denominator is exactly 0. So that, you know what, that just, forget about that one. However, when we do it to the other definition, limit as h approaches 0 of f of x plus h minus f of x all over h, well, this one works out much better. This one, oh yeah, that's a winner. So this guy right here is known as the derivative as a function. Therefore, that's why I had this written down up here. Now, the derivative as a function allows you to take a derivative and then plug in whatever values of x you're interested in. However, it should be pointed out, though, that we started with a function, we took a derivative, we got another function. So the concept of higher derivatives can exist when you start taking the derivative of something that's already a derivative. We'll touch on that in a future video.